At this point, you should feel pretty comfortable, I hope, simplifying single radical expressions using the guidelines that were developed in an earlier module. We're now going to move on to consider operations with radical expressions. That would be where we add, subtract, multiply, and divide them. And we're going to first consider addition and subtraction. Now, it's going to be important to be reminded of what we mean by like radical terms. And that would be terms that contain the same radicand and the same index. Now, for our first example, we're going to look at part A here, which is 2 times the square root of 5 plus 3 times the square root of 5. And I hope you'll agree with me that these are like radical terms because they contain the same radicand 5 and the same index, which is understood to be 2 here for square root. So all we really need to do now then is to simply add together the coefficients, which are 2 and 3. So we will then have 5 then times the square root of 5. Now why don't we divert for just a moment to justify this just a little more formally. If we go back to the original problem, what we could do, I think you'll agree, is to factor out a square root of 5 from each term. We would then have left inside 2 plus 3. Then adding the 2 and the 3, we would get then 5 times the square root of 5. So just a reminder that the justification for combining like terms of any kind is actually the distributive property. So now let's move on to part B. We have the square root of y plus the square root of y. And of course the coefficient on each is understood to be 1 here. And I think you'll agree that those are also like radical terms. And so all we need to do then is to add the coefficients, so we end up then with 2 times the square root of y. For part C, the square root of 2 plus the square root of 3, you can see that the radicands are different in each case, so these are not like radical terms. So we're finished. That's as far as you can go in terms of simplifying that. And in part D, we have the square root of 2 plus the cube root of 2. Now, although the radicands are the same here, the index is different in each case. We have a 3 in one case and a 2 in the other. So, again, we're not able to simplify or combine these terms together any further.